One of the basic types of proportion is direct proportion. Check out some examples of this type here in Mathematics of Engineering. Recall what direct proportion is. This is a type of relationship where the two quantities involved experience similar trend. That is, for example, there are quantities x and y. If x increases, y also goes up. Our first example. The force acting upon an object can be modeled by the equation F is equal to m times a. The force on an object is increased from 35 kilonewtons to 140. If the mass of the object remains the same, find the factor by which the acceleration changes. Start by identifying the given parameters, that is, with the initial and final situations. The first force is 35 kilonewtons, and this is increased into 140, making the final force as 140 kilonewtons. The mass for the initial and final cases remain the same. So the given formula F is equal to m times a. You can take this as F is to m times a. Write this in fractional form, making F over m times a. So for the first case, we get F over m times a with their initial values where F is 35 kilonewtons. The second case has the same parameters valued in their final condition, that is F is 140 kilonewtons. Using cross multiplication, the equation turns into 35 times a final is equal to 140 times a initial. Divide both sides by 35 to get the final acceleration as 4 times the initial acceleration. So from this relationship, the factor is 4. Example 2 states, the length of a piece of wire is directly proportional to its weight. A piece of wire is 25 centimeters long and has a weight of 6 grams. Another piece of the same wire is 30 centimeters long. Calculate the weight of the 30 centimeter piece of wire. Identify the given parameters again. 25 centimeters of wire weighs 6 grams. This is case 1. Then we are to determine the weight of 30 centimeter length of wire. This is case 2. In fractional form, we have case 1 as 6 grams over 25 centimeters, then case 2 is x over 30 cm. Through cross multiplication, we get x times 25 cm is equal to 6 grams times 30 cm. Divide everything by 25 centimeters and get the value of x as 7.2 grams. For the next example, a brick falls vertically after being dropped. It falls a distance d meters in a time of t seconds. D is directly proportional to the square of t. The brick falls 20 meters in a duration of 2 seconds. We are to look for A, the equation for D in terms of t, B, the distance the brick falls in 3 seconds, and C, the time the brick takes to fall 605 meters. To answer the first requirement of the equation for D in terms of t, we interpret the premise of D as directly proportional to the square of t. The proportionality symbol is used to relate the two parameters, and this cannot be solved until we change the proportionality symbol into an equality symbol. The transformation is done by adding k, a proportionality constant. Now for the premise which states that the brick falls a distance of 20 meters in 2 seconds, plug these values into the equation to have 20 is equal to k times 2 squared, simplified as 4k as equal to 20. Divide both sides by 4 to get k as 5. Now that we identify the constant, the equation for this situation is then taken as d as equal to 5t squared. For the second requirement of taking the distance traveled by the brick at t equal to 3 seconds, using the same equation, substitute 3 in t to have d as equal to 5 times 3 squared, or 5 times 9, which is 45 meters. For the third requirement of determining the time when the brick traveled 605 meters, using the equation, we get 605 as 5t squared. Divide everything by 5 and get t squared as 121. Now take the root of both sides and arrive at t as equal to 11 seconds. We move to example 4, which states, in a spring, the tension T in newtons is directly proportional to its extension, x, in centimeters. When the tension is 150 newtons, the extension is 6 cm. A. Find the formula for T in terms of x. B. Calculate the tension in newtons when the extension is 15 centimeters. And C. Calculate the extension in centimeters when the tension is 600 newtons. First is to generate the equation of T in terms of x. The premise says that T is directly proportional to x. Transform this into T as equal to k times x. With a given T of 150 newtons and x as 6 centimeters, we get k as 150 newtons over 6 centimeters or 25 newton over centimeters. Thus, the equation becomes T as equal to 25x. The next requirement is to determine tension when the elongation is 15 centimeters. Using the equation, we get T as 25 times 15, where centimeters is cancelled out, so T is 375 newtons. The third requirement looks for x when T is 600 newtons. Plug 600 into the equation and get 600 newtons as equal to 25 times x. Divide each quantity by 25 and have x as 24 centimeters. For example 5, the fuel consumption of a car is 15 liters of diesel per 100 kilometers. What distance can a car cover with 5 liters of diesel? The proportion can be written in fractional form as case 1, that is 15 liters over 100 kilometers. Then case 2 has 5 liters over x. By cross multiplication, we get 15 liters times x as equal to 5 liters times 100 kilometers. Divide them by 15 liters and get x as 100 over 3 kilometers or 33.33 km.